Good morning. Today we will see a new parameter called as Poisson's ratio. The ratio of the lateral strain to the longitudinal strain is a constant for a given material when the material is stressed within the elastic limit or stresses within an elastic limit. So this ratio is called Poisson's ratio, which is denoted by 1 by m or mu lateral strain by longitudinal strain or lateral strain divided by linear strain, whatever it is. So longitudinal strain or linear strain, which is given by delta L by L, and lateral strain is nothing but delta B by B or delta T by T or delta D by D. So 1 by m, that is the Poisson's ratio, varies from 0.25 to 0.33. For example, for rubber, it varies from 0.45 to 0.5. Now let us see the uniaxial stress, that is nothing but the stress which is acting in one direction, sigma. So sigma which is acting in one direction. So sigma is given by, stress is given by the load by area. Or strain is given by stress by Young's modulus. Strain is given by stress by Young's modulus. Now biaxial stress. Now let us assume that stress acting along the horizontal direction, which is taken as x direction, sigma x, and the stress acting in y direction, that's a vertical direction, let us take it as a sigma suffix y, sigma suffix y. So now the stresses are acting in both the directions, sigma x and sigma y. How to write down the strain equation in terms of these two stresses, sigma x and sigma y? So we know that Poisson's ratio is nothing but lateral strain by linear strain. So I told you already lateral strain is nothing but the side effects, that is sideways. For example, if this is having a rectangle section and this is the length, for example, and the cross section dimensions b and a t, b and a t. So delta L by L is nothing but the longitudinal strain for this sigma, and delta b by b and delta t by t is nothing but the lateral strain for this sigma. Coming to this, coming to this. Now, how will you write the lateral strain with the help of Poisson's ratio? Lateral strain is equal to 1 by m into longitudinal strain. Lateral strain is equal to 1 by m into longitudinal strain. That we have to remember, okay, while writing the strain equation for this biaxial stress system. Now, Ex represents the strain in x direction. Okay, strain in x direction. In x direction, sigma x. Now we are considering the x direction. So sigma x stress by Young's modulus. Stress by Young's modulus is strain. So Ex in x direction, sigma x is the stress in x direction, divided by E is the strain, okay, which is nothing but the longitudinal strain in x direction. Now, compared to this, when you're considering only sigma x, this side becomes the lateral strain when you're writing the strain expression in x direction. So when I apply or when I consider only the sigma x, this side getting decreased or getting compressed, we can say. That's why we are introducing this minus sign, minus. So when we consider the stress in x direction to write the strain equation, so this becomes see 1 by m into longitudinal strain. So this becomes the lateral strain for x direction. So minus 1 by m into sigma y by e. So sigma y by e is nothing but the longitudinal strain in y direction multiplied by 1 by m. That becomes the lateral strain in y direction when you write the strain expression in x direction. So E is constant, it's 1 by E, sigma x minus 1 by m into sigma y. Now when you write for sigma EY, strain equation in y direction, okay, so this becomes the longitudinal strain. Okay, you're writing expression for strain in y direction. So sigma y by E. So with respect to this, when you apply the stress in y direction, so this becomes the lateral one where it is getting reduced or decreased. So minus 1 by m. So 1 by m into longitudinal strain gives you the lateral strain. So minus 1 by m into longitudinal strain in x direction, that is sigma x by E. So minus 1 by m into sigma x by E is nothing but the lateral strain when you consider strain in y direction. So E is constant, you can take 1 by E outside, so sigma y minus 1 by m into sigma x. Now triaxial stress. Let us consider the stresses acting in all the three directions, x, y and z direction, that is sigma x, sigma y and sigma z. Ex, same way. Now you are writing sigma Ex equation in x direction, Ex. Sigma x by E is nothing but the longitudinal strain in x direction, and this strain in y and z direction becomes the lateral strain. Okay, lateral strain. So lateral strain is nothing but 1 by m into Poisson's ratio. So when you consider only the x, the lateral strain, that is in y and z direction, is getting decreased, compressed. So I have to introduce minus sign here, minus sign here. So minus 1 by m into sigma y by E, which is nothing but the longitudinal strain in y direction, and minus 1 by m into sigma z by E, which is the longitudinal strain in z direction. So E, take it as a common, sigma x minus 1 by m into sigma y plus sigma z. Similarly, sigma y when you consider, sorry, Ey, if you consider sigma y by E is the longitudinal strain in y direction, sigma z and sigma x becomes the lateral strain. So lateral strain is equal to 1 by m into longitudinal strain in x and z directions. So we can simplify like this. Similarly, Ez is equal to sigma z by E, which is the longitudinal strain in z direction, and sigma x and sigma y becomes the lateral strain. Taking E outside, you can simplify to 1 by E into sigma z minus 1 by m into sigma x plus sigma y. Again, recall the same thing, the triaxial stress system. Now you can see here sigma x, sigma y, sigma z, all the three stresses are under tension and mutually perpendicular. For example, if any one force is compression, for example, if sigma x is compressed, sigma y tension, sigma z tension, sigma x alone is compressing means we have to introduce minus sign here. For example, minus sigma x by E, and here if I introduce minus say here, minus into minus plus 1 by m into sigma x by E, and here if I introduce minus for sigma x, minus into minus plus 1 by m into sigma x by E. So if longitudinal strain is tensile, the lateral strain will be compressive. That is, if x is tensile in x direction, y and z will be compressive. For example, if y is tensile, this z direction and x direction lateral strains will be compressive. If lateral strain is compressive, the lateral strain will be tensile. So these things we should keep in mind while writing the strain equations, Ex, Ey, Ez. Okay, that's why we get here minus signs here, right? If this is tensile, this becomes compression. Okay, tensile compression compression, tensile compression compression. Okay, the ulta happens if this is compression, so this will be introduced as a minus sign. If sigma x is compression, sigma x you should put it as a minus sigma x by E. Here minus into minus plus sigma x by E into 1 by m, and here minus into minus plus sigma x by E into 1 by m. Thank you.